and discuss ways to advance technological innovation for the development of the water industry. This is the second forum being held, followed by last year. This year's event, in this year's event, distinguished guests from 10 institutions and clusters throughout 5 countries are participating. Unfortunately, due to COVID-19, we only have a few of the presenters and panels on site, and the entire event is being live broadcasted online and on YouTube as World Water Cluster Leaders Forum. Also, we have simultaneous interpretation services. Channel 3 is for Korean and Channel 4 for English. So now with this, let us begin the official event. Now we will begin the World Water Cluster Leaders Forum 2021. First, from Daegu Metropolitan City, we have Mr. Chung Hae-yong, Vice Mayor, for his welcoming and congratulatory remarks. Let's welcome him with a big hand.
Ladies and gentlemen, nice to meet you all. And from now on, we are going to officially start the 2021, the Second World Water Cluster Leaders Forum. Nice to meet you all today. I am Vice Mayor for Economic Affairs of Daegu Metropolitan City, Chung Hae-yong. And today we are also joined by the stakeholders around the world in terms of the World Cluster, and it's my honor and great privilege to host the second World Water Cluster Leaders Forum in the city of Daegu. Despite the challenges of the COVID-19 around the world, we are also online participants from other different countries as well. Despite these challenges, I'd like to extend my gratitude to all the stakeholders in the global World Cluster with sincere gratitude to your participation. In particular, we are also joined by POV's Director Lian Nguyen from Singapore, as well as online participants and the Chairman, Qatar Water Partnerships, the President George D. Krups, and Cleveland Water Alliance, CEO Brian Stubbs, and Vienna University's College, Professor Dage Anderson, and the U.S. AWWA, the President Xiao Sam, and the U.S. WWEF CTO Bear Liner. We are so many representatives and the distinguished guests today. Thank you very much once again. For the safe and the clean management for the water resources, these are our key issues and challenges, and these are key objectives on behalf of the world and the global water cluster. Throughout today's forum, we'll be also talking about the issues, and I am very sure that we can take a lot of the achievements in these fields. A lot of the know-hows and experiences will be also shared today, and will be also promote the human exchanges. And furthermore, severe water-related challenges along with the key technologies will be also discussed together, driving a lot of the solutions and the fruitful outcomes. And the key theme of today's forum is the distilled water best practices, as well as the countermeasures in dealing with the climate change. We'll be also unfolding a lot of the key solutions and the fruitful outcomes in the global water cluster. I also believe that we can meet all of you in person to really exchange and discuss very fruitful outcomes and the solutions in the fields. I really hope that we can take a lot of developments in terms of the relationships. And to all the participants and stakeholders, all the distinguished representatives from the key industries and key countries, once again, thank you very much for your participation. I really hope that we can solve the COVID-19 crisis as fast as possible. Thank you very much once again. It was the welcoming remarks from the Vice Mayor for Economic Affairs of Daegu Metropolitan City, Chung Hae-yong, the key objectives of the World Cluster, as well as the roles of the Daegu Metropolitan Metropolitan City have been discussed. Before we get started, we are going to take a group photo. So to all the distinct guests and participants, please come up to the stage for a group photo. Thank you.
예, 감사합니다. 모두 자리에 착석해 주시기 바랍니다.
Thank you very much for your cooperation. Please be seated. That was the end of the opening ceremony, and we are going to officially start the forum with the session. For the first session, the theme is Digital Water Industry with the best practices. We are going to have the presentation as well as the panel discussion. For the first presenter, let me introduce the Mr. Lan Yuen, Deputy Director of the PUB, Singapore's National Water Agency, will be the first presenter. And SIWW, he is the Executive Director. He's going to talk about the strategies in terms of the key transformation in the water cluster. Due to the COVID-19, he is joining us with the online platform. Let us welcome him with a big round of applause.
Hi, good afternoon, everyone. And thank you to the organizers, Korean Water Partnership, for inviting me to this forum. It's a pleasure to come back to Korea after such a long time and to meet many Korean friends in this lovely city of Daegu. Today, I will be sharing Singapore's experience in our water digital journey. First, let me give you a short introduction of PUB. I believe many of you know who PUB is. We are the National Water Agency of Singapore, and we manage the entire water cycle, from catchment to drinking water treatment and collection and distribution, to use water management, use water recycling, and desalination. Not long ago, PUB was also appointed as the Coastal Protection Agency. As the Coastal Protection Agency, we coordinate the effort to protect Singapore's coastline from the threat of sea level rise and mitigate both inland and coastal flood risks. So our mission is captured in these 4 statements in the slide: supply good water, reclaim used water, tame stormwater, and resist rising seas. So for PUB, why do we embark on digital journey? I think as a utility, there is a need for us to embark on this because there is a need for us to transform. And why do we do so? We have 4 key drivers for doing so. Number 1, there is rising water demand, both from the municipality as well as industry. Number 2, there is also a need for us to manage rising costs and to enhance efficiency and productivity. Thirdly, many of our workers are retiring, and it's very difficult for us with a small working population to fully replace some of this aging workforce. And finally, there is increasing public expectation in terms of service delivery, and through digital technologies, we can improve our service delivery. But besides these drivers, there are also risks for us of not doing anything at all. So for example, with increasing cyber threats, we need to keep abreast with the latest technology. We also need to make sure that our systems, our technologies do not become obsolete, and that our operations continue to function reliably and efficiently in an environment that is getting more and more complex. So to address these drivers and risks, PUB in 2018, we developed a 5-year smart roadmap to make PUB a smart utility. And in this roadmap, we want to implement smart solutions across our entire operations, from planning all the way to operations and maintenance. And in this roadmap, we have identified 5 technology enablers, and these are IoT, Internet of Things, data analytics, digital twin, artificial intelligence or AI, and autonomous systems. Now, many of these enablers already have tried and tested use case that are deployed successfully in industry. So PUB can readily adopt these solutions, leveraging on these technologies to deliver our mission easily. So how do we do that? This slide shows you how these 5 enablers conceptually interface with one another to improve our operations. So for example, the box in green, we use IoT sensors to capture the data across all our different operational processes. Then we send this data to our operations monitoring system for system oversight. And then to enable us to make data-driven decision makings, we use data analytics, we use AI, we use digital twins, simulation softwares to inform us in terms of the decisions that we need to take. Through a data lake, we then combine this data, we analyze them from different sources through all the different sensors, and that will give us insights in terms of how we can maximize and operate our operations more efficiently. So in terms of approach, we adopt a 3-pronged approach in terms of implementation of our smart roadmap. We do it by breadth, by depth, and at enterprise level. As the name implies, by breadth, which means we look at across all our operations, whether is it drinking water, wastewater, stormwater, to identify applications that can be applied across the business unit. By depth means we look at a particular function. For example, our water treatment works, and look at how we can re-examine our workflows, our processes, identify areas where smart solutions can be implemented across that business unit. And then where there are opportunities arises across the enterprise level, we will then aggregate the demand and implement solutions. I will share a bit about each of these in the coming slides. So by breadth, you would see this slide shows we are exploring applications that can apply across all operations. So by being a smart utility, we want to have a smart drainage grid, a smart plant, a smart water grid, as well as a smart sewer grid. So in essence, what we want to do by breadth is to, first and foremost, deploy sensors across our different systems to capture data. Now, once we capture the data, we want to be able to analyze the data so that we can run simulations, we can do scenario planning, and we can do predictive and risk management measures. Thirdly, at the system level, across all our different systems, we want to leverage on robotics or autonomous systems to reduce our reliance on manpower, especially for jobs that are either dirty or dangerous. Finally, we want to leverage on a C3, command, control, communication system, for us to have overall oversight across all different business units, as well as productivity tools to automate workflows and enable collaboration and knowledge management. By depth, we want to deploy smart technologies within our business functions. So for example, in this particular slide, for our smart plants, we want to deploy sensors to monitor integrity and performance of our assets. we will adopt predictive analysis tools to improve our resource efficiency. We will also use augmented reality, wearables, and robotics. For example, you see the picture at the bottom where the man is with the finger pointing out. He's actually wearing an AR smart goggles to retrieve information on how we can operate and maintain equipment, and using this information to communicate real time using AR with the officers in the control room. So he doesn't have to actually go into a dangerous room, for example, to do some of these operations. Now, we also will be, our officers are also wearing wearables now to monitor the safety, because our plants can be quite big. And so real time with a wearable, they will be able to know whether the person is under danger, for example, if they're going into enclosed spaces. Lastly, we are also using robots, for us to do, for example, collection of water samples, or even patrolling our facilities around the clock at night, for example. So some of these projects are currently piloted to establish a proof of concept and the value of the technology. And if it works, then we will roll them out on a larger scale when we either build new installations or when we are doing a tech refresh. So the earlier slide was talking about our smart plants. In terms of our smart networks, across our 3 networks, water supply network, stormwater drainage network, and the sewerage network, we are likewise expanding our coverage of sensors, as well as implementing new and enhancing existing systems for monitoring and analytics to enable preventive, predictive actions to be taken. One exciting project that I'm happy to share with all of you today is the installation of 300,000 smart water meters across Singapore. It is our AMI project. Today, all our water meters are read manually by people to go to the house. They read the meters once every 2 months. But with AMI, we are able to collect the data on an hourly basis. This enables us to do a few things. Number one, it allows us to understand water consumption patterns. It allows us to detect anomaly, for example, leaks sooner, so that we can take action quicker to reduce water loss. And finally, with this analytics, we can able to engage high water users on their water consumption so that to drive water conservation. We have awarded this tender for this project in April this year, and we will be implementing this completed estimated end of 2023. Finally, at the enterprise level, we are also deploying solutions. Typically, these solutions are looking at customer service and enhancing workplace productivity. So, for example, we are under the Ministry of Sustainability and Environment, and we have an app called a One ENV app, where members of the public can receive notices like heavy rain warning, flood notification, or even access to various e-services through the mobile app. Within PUB as well, we have also implemented a knowledge management system called a PUB Wiki, you know, like the Wiki, W-I-K-I, PUB Wiki. We also have a HR and learning management system called PUB People and PUB Learn. We also have an asset management system that automates all our asset management workflows, as well as a command and control C2 system called the Intelligent Water Management System. Now, obviously, for all these systems to work, we need to ensure that, you know, there is a reliable system to be able to host and to put all the digital solutions. So we are upgrading and also modernizing our legacy systems and leveraging on the cloud for scalability. Obviously, smart projects carries a bit of risk. So in particular, cybersecurity. So we have also drawn up a cybersecurity master plan that we will execute over the next 3 years to ensure the security, resilience of our systems against cybersecurity threats. Finally, digital journey is not complete if you don't get the workers and the workforce on board. So Digitalization is not only just about the solutions, but also about our people. So therefore, we are also investing efforts to educate our workforce in terms of their digital, data, and cyber literacy and competency, so that they are able to use these technologies well when we implement them. So like many utilities around the world, digital transformation to PUB is born out of a need to improve the way we operate and to deliver our mission now and into the future. So I'm happy today to be able to share our journey with you at this forum. For those who are interested to learn more and have the opportunity to visit our facilities, I extend an invitation to you to join us at Singapore International Water Week, which is happening next April in Singapore. So SIWW will happen as a physical event. We are planning for this. And I think if it happens, it will be one of the first in-person water event in Asia since the pandemic. But for those who are interested but not able to join us, there will also be an on-demand access component for audiences who wants to learn but not unable to come to Singapore. At SIWW next year, we will be focusing on 3 urban water management issues, in particular, climate resilience, the whole idea of extreme weather events, floods, sea level rise, net zero or circular resource or decarbonization or reduction in carbon emissions, and lastly, digital water, which is the topic of today's session. I understand that Korean Water Partnership is forming a delegation to the event, and I'd like to thank them for their support. For those who are interested, I hope you can join them as well to visit us in Singapore, where we can continue our learning and sharing our mutual experience. So with that, I thank you for your time. I look forward to having the panel discussion later on, and I wish you a wonderful afternoon. Thank you very much.
예,
Thank you very much for the presenter. Once again, I'd like to give a big hand to the Deputy Director Lion Yuan for your great presentation. And from now on, we are going to have the panel discussions on the theme of the digitalizing water, sharing the experience around the world. And the moderator will be proceed the panel discussion. The moderator is the professor of Yeongnam University, Professor Chung Jin-young. Please come up to the stage.
예, 안녕하십니까.
Good afternoon, everyone. I am the moderator, Professor of Yeongnam University, Chung Jin-young. Nice to meet you all today. First of all, the water digitalizations and the digital water transformation is the key theme of this session, and I'm very honored to play as the moderator. We'll be also inviting the 7 panelists, including myself. First, we also have online participants as well. So let me first introduce the online panelists, first of all. And when your name is called out, please stand up or wave your hands from the online platform. First of all, the presenter, Mr. Lion Yuan, Deputy Director of PUB Singapore's National Water Agency. Please come up to the stage. Please be seated next to me. Thank you. We also have participants, offline participants. Jordi Cross, President of Catalan Water Partnership. Can you see his face on the screen? Okay, we are also going to greet him later again. We are also joined by the CEO of the Cleveland Water Alliance, Brian Stubbs. He's also joining us with the online platform. We are also going to share his faces. We also have joined by the Deputy Director, No Suk-hyun of Daegu Metropolitan City as a panelist. And I think that we can also share the faces from the online participants. And we also have the panelist, Professor Lee Dae-sung of Gyeongbu University. So let us also give a big round of applause. We also have a panelist, Lee Chi-woo, Director of the Korea Environment Corporation, Lee Chi-woo. Once again, I'm going to introduce the participants from the foreign countries. From Spain, we are joined by the President of Catalan Water Partnership, Jordi Cross.
해주셨어요. 다음에
Next, we are also joined by the CEO of Cleveland Water Alliance, Brian Stubbs. Thank you. Thank you very much for your all cooperation. We are also having a total of the 7 panelists for this panel discussion. The President, Jordi Cross, is joining us, and I'd like to also ask a question to you first of all, and we are definitely willing to listen to your answers as well.
Do you have any comment?
First of all, thank you very much to the organization for inviting us. It's really a pity we cannot be in presence, but hope next year we will be able to attend. Regarding the questions you ask, I think that currently there are some artificial intelligence applications that are really better than human judgment, but not all of artificial intelligence applications are better. According to a study of Artificial Intelligence magazine, 85% of artificial intelligence applications failed in their implementation, and many of them because they expected much more than was really able to execute. But in the water sector, there are a lot of artificial intelligence applications that are very successful. For example, in computer vision, now it's possible to detect asset conditions thanks to artificial intelligence systems or vision using it. Or in audio recognition to detect vibrations and noise for maintenance. And this is currently applied in some places. I would say that artificial intelligence has some advantage over the human characteristics. The first one is the calculation speed or the computational power. You know that currently you have in your pocket a mobile phone that has more power that the IBM computer used to land a rocket on the moon. And this will go increasing. The second one is the capacity of memory of the number of data that can be managed. That it's clear much more than many of human capacities. And the third one is the replicability. One of the problems of the human judgment is that it's very difficult to replicate. It's difficult to learn, to teach people. And fortunately, computers are very easy to replicate. But this does not mean that everything is possible and everything can be done. Like in human, the training process is very important. And in this case, to teach this artificial intelligence, there is still some challenge. One of the most important, and I think that all of you have heard about it, is the bias problem. According to what we teach them, they will be able to recognize or to really detect things or not. Another problem is the data scarcity. We don't have all the information of everything, so we can teach this intelligence to be able to make everything. But there are also some issues in the data privacy and security, or perhaps it's not our case mainly, but the ethical challenges or legal challenges is very important. And there's a third problem, I think, in the application. When you try to implement some artificial intelligence applications, there are some big problems. One is the truth deficit that is implied in the question you made. Is it better or not? And there's another problem that can generate some disagreement, that it's the big expectations people have on intelligent artificial. As I have said, currently there are applications that are better, but not all applications are better, and not everything can be done with the artificial intelligence. I work in the quality systems, and I always say that measuring temperature, even you have the best artificial intelligence system, you will not be able to detect conductivity. Perhaps you are making Coca-Cola, yes, but in a river it will be impossible. In the Catalan Water Partnership, we are working in some projects as a cluster with more than 120 companies in Catalonia, in Spain. We promote the development of projects in artificial intelligence, for example, to detect leaks in sewer system, or to make a tool to optimize the anaerobic digestion in wastewater treatment plants. I think, as I have said, yes, currently artificial intelligence in some applications is better than some human knowledge or judgment, but there are a lot of applications that are still unworking.
네, 감사합니다.
Thank you very much. Dirty Cross mentioned about data memory expansion and data privacy, education, and using AI to supplement the lack of data. Next to Brian Stubbs, I would like to listen to comments or questions if you have any, and then we will move on to Mr. Ryan Yuen. So, Brian Stubbs, do you have any comments or opinions?
And good afternoon. It's an honor, and I so wish I could be there with you in person, and I'm certainly hopeful that next year we will be, and also looking forward to getting to Singapore next year as well. To the question of big data and AI, we take an approach that these are simply tools in the innovation and technology toolbox. And we're big fans of this innovation and this work. And there certainly are tremendous opportunities of things that we couldn't afford to do without this next and new generation of IoT sensors, analytics behind those sensors. So I'll give you an example. We work with many drinking water utilities in the Great Lakes region of the United States. And as part of that work, Traditionally, you had humans go out and take water samples in the Great Lakes and in the watershed. This was enormously inefficient and expensive and time um, time sensitive was not an issue. So often we would get readings and get samples back to a lab and put into an Excel sheet and eventually upload it to somebody else within the system. So it could be 6 months after a water sample was taken before it got into the right hands. Today, as we build out our smart Great Lakes watershed, starting with Lake Erie, where we're implementing and deploying thousands of sensors in different ways, shapes, and fashions, whether behind me in my image, you can see one of our 4 water intakes for the city of Cleveland on Lake Erie, and we have 4 buoys out around the intakes, 3 intakes, each with their dedicated buoy, and a 4th buoy that's further out. We're able to gather real-time or near real-time information and data, and this leads into similar projects throughout the lake with other utilities. So suddenly we have a lot of data coming. So first of all, without big data and without, analytics driving this discussion, we wouldn't have this and we'd still be living in very much a different era. Today, we can actually get real-time data and start to develop models, analytic models, and this is why it's so important for the prediction of certain water chemistry coming at us. In this case, we would be really prone to look at 2 things of interest. The first would be cyanobacteria, or the byproduct of harmful algal blooms, which is a major issue within our region of the world, and has, infamously shut down the city of Toledo, just an hour and 20 minutes from where I'm sitting tonight, for me, this afternoon for you. Shut down their water system for 2.5 days. And the other is hypoxia. So within our water technology test beds, we actually just finished up a very interesting analytics, AI, whatever you want to call it, application to develop an early warning system for hypoxia, which is a major need for our water treatment operators to know what's coming at them and to prepare. So I look at it as what is applicable and what is not applicable. We are very, very concerned with what does the market need, and if the market needs this, then how can we do things more efficiently and effectively? And artificial intelligence can certainly help us with that. I think Jordy hit on a lot of interesting points there. Is, one, data can be unemotional, which can be a good thing, but it's still like just with data, bad data in is going to give you bad data out. Those who designed the architecture for our analytics and AI operating our systems, it has to be looked at carefully. There's extreme concerns around cybersecurity for us. So, I'll pause there and let that kind of be a kickoff of a conversation. The question proposed to me is big data and AI judgment really better than human judgment? No, it's a tool in the toolkit. And that's how we kind of look at this as what will allow us to do things better, to improve efficiencies, and to ultimately improve how we deliver water quality to our residents and to our industries in our region.
예, 감사합니다.
Thank you, Brian. You mentioned about the water quality management and what happens in your region where you live in Cleveland, and also hypoxia, how you predict hypoxia using AI. So regarding these 2 comments, Ryan Yuan, do you have any comments or opinions, please? 네.
Yeah. So, yeah. So I first and foremost, I agree with Brian's point that AI, big data, all these are tools that we can use to help us in terms of digital transformation. But I'm speaking from the point of view of utility. I think first and foremost, as a utility, we need to be clear what is the intent, right? And if you're clear what is the intent, how are you going to use digital tools to transform? If you know the intent, you know the outcome, then the toolbox is just a list of possible tools that you can use to deploy to be able to collect the right data, to be able to use and analyze the data. Because one challenge is if you don't know what you want, you go out and collect the data. The data might not be in the right form. It might not be clean for you to be able to make the right analysis. So therefore, it's always important to know what is the end outcome and therefore what kind of data you need, what tools you need to collect the kind of data so that the data can then be analyzed accurately to give you the right results, to give you the right outcome that you want. So I think that process is something as a utility we need to internalize. The toolbox is just toolbox. The technologies, the solution providers can help you to customize that toolbox to something that you need. But as a utility, you need to know what you want. So that's one. The second point I would like to just add on is the human dimension. I think we cannot underestimate the fact that digital transformation is not just a concept that management says, I want to do it. It has to be bought in by all levels, including the operator, because operators have been operating in a certain way for many years. Many of our operators have been there for 10, 20 years, and they are used to a certain way of doing this. To them, digital is something sometimes very scared, very fearful, because not only technology, but they worry that they will take away my job, right? And if I implement analytics, then I have no need for a worker. So in PUB's case, we do a deliberate exercise of engaging the staff, telling them the benefits of digital because it helps them to do their job easier, better, and faster. So that is the part that I think even for transformation, we as PUB, we pay a lot of attention, not only on the technology side, but also on the hardware, I say the human side. And I guess that is just my comment on the two comments by the other panelists. And maybe I hand over to the other panelists.
예, 네, 감사합니다. 이어서 우리 대구시를
And while there's pursuing the smart city from the Daegu Metropolitan City, we are also joined by the Deputy Director No Suk-hyun of Daegu Metropolitan City. So please feel free to share your comments or any questions. On behalf of the Daegu Metropolitan City, these transformations and the training and the digitalizations are a lot the promoted. And when it comes to the key objective of why we are having the transformation and digitalization is absolutely, these are essential for the easier and the convenient access in our work. On behalf of the Daegu Metropolitan City, we also have the 8,000 kilometer in terms of the waterworks and the 6,000 of the sewage water the lines, and we also have about 350 million won in terms of the cost of the budget for handling the waterworks and the sewage, the water routes as well. And these also require a lot of the personnel and the effort as well. Existing the water quality, pressure, and ecosystem management. And we are trying to recognize the accident incidents throughout the waterworks systems. In this regard, the limitations are absolutely existing. In order to deal with these challenges, we are also trying to solve those challenges by improving our waterworks system. The data standardization and those standardized information should be absolutely applied. Of course, we have a huge amount of the data, but how we are going to utilize those data, it's also very essential, requiring the more data standardizations, expectations through the irritations and the leakage and the water quality and the water resource management can be also done by using the AI the digital transformations. I believe that these are key objectives that we can go beyond the limitations when it comes to only the limited the human capacity. And we also have about a lot of the all the spectrums water recycling systems based on the AI and the digital, the ecosystem management are being a lot promoted from the Daegu metropolitan cities. We also have a lot of the dedicated waterworks or the water sewage authorities, but in this regard, such the processes will be also digitalized as the key objectives, as the key challenges. In terms of the four sewage plan, the smart sewage systems will be also trying to lead about the 41 billion won. Those the spectrums that we cannot only cover with the human personnel absolutely could be more highlighted via the digitalizations. And I do also believe that I'm also looking forward to getting more information and comments from the key leading institutions and countries. Thank you very much for providing your comments. You also highlighted about the key objectives and obligations are ongoing by the Daegu Metropolitan City for the improvement and the water resource management. So Professor Lee Dae-sung, could you also share your comments as well? I am professor of the Kyungbu University, Lee Dae-sung.
To come to Korea even in outbreak of Omicron, right? Thank you very much. 오늘 아마 앞에서 말씀하신 들
And in addition to the comments already mentioned before, the digitalization or AI could be recognized as the toolbox. Of course, we cannot handle all the issues only with the digitalization. I also got a PhD degree as of the 2000, and my topic for the thesis was the optimization on the water management, including the water sensors, and especially for the waterworks and the sewage, the system. And I do also wonder that how we are going to apply those informations. For example, the AI learning and all the data would be, and how these data will be applied. But compared to the past, about 2 decades ago and the current, I don't think that we have done a lot of the significant progress in terms of the using the smart with a lot of the different sensor. Of course, we do have a lot of the huge amount of the data, but the data itself and for the water works as well as the water treatment. And I don't really think that there has been a lot of this significant progress in when it comes to the utilizing those data for our waterworks and the water treatment. Of course, we have done a lot of the discussions on the themes of the waterworks and the water sewage, the systems, and how we are going to use the digitalization. When it comes to digitalizations to our water systems, like the safety of water or the level of the water quality, for example, for the sewage, the water, are to be also more highlighted. And when it comes to digitalization, the carbon neutrality as a key theme, or the energy efficiency has been also put a lot of attention these days. And as we also discuss a lot of the, for example, for the waterworks and the sewage, how we are going to use those resources. And these are the discussions that we have had a lot of the times before. For these objective of the system and the diverse objective throughout the system and the processes could be also more highlighted how to really operate this system in a more efficient manner. And digitalization could be also to touch upon the optimizing the technologies. And we also have the concern about the sensors, first of all. We also have to understand that the sensors and the current status of the sensors, along with all the the challenges and issues. Therefore, we can have the more rooms for the further developments in the digitalizations as well as the utilizations of the AI. For example, how we are going to contribute those AI role models for the vehicles operators. Deep learning, AI have already built as a toolbox or the online tools. But in this regard, we can also demonstrate a lot of the great outcomes based on the AI models, which are already available these days. So we can have a lot of potential to develop those technologies. In this regard, what type of data and how we are going to fulfill those requirements by utilizing the data, and based on what level of the criteria or standard, we can also talk about the very different scenarios and the stories depending on the level and the status of the data digitalizations. And when it comes to smart waters in Singapore, you also touch upon a very detailed examples of the smart water and plan in your country. And in this regard, for the digitalization, what approaches or what strategies have been highlighted in the Singapore considering these circumstances? And absolutely, we are talking about the energy efficiency and the carbon neutrality these days. So regarding the two elements, how and what types of objectives are being a lot highlighted for achieving carbon neutrality as well as energy efficiency in Singapore? So I'm also looking forward to getting your answers as well. Thank you very much, Professor Lee Dae-sung, for raising good comments. So AI utilization and optimization for the waterworks was one of the key theses for your PhD degree. So your question is that the distillized water and what is objective of using distillized water? Of course, we have a lot of initiatives, for example, for the carbon neutrality, to reduce the water consumption and reducing carbon emissions. So probably these are the topics that you have touched upon regarding your questions. Director Ichi-woo, I'd like to also raise a comment. AI, big data, are the topics that I have studied personally. Even though we have a lot of the pictures on the dogs and the cats, AI cannot really fully analyze the differences between the pictures on dogs and cats. Of course, when it comes to a lot of the huge amount of data, there may be the part of the data that can be analyzed by the AI. There have been a lot of the data and the digitalized the data. Of course, it takes a lot of the money and the time to fully digitalize the data and information. So if you have any comments or the answers, I'm also free to listen to your question. We are also joined by the director of the Korea Environment Corporation, Ichi-woo. So if you have any comments or questions, please also feel free to share your opinions. I am Ichi-woo, director of the Korea Environment Corporation, or EXCO. And first of all, I am very honored to meet you all, the panelists here. And let me also briefly introduce about my organizations. ECO, or K Environment Corporations, is to implement the policies, and we have a 41 years of the history for the air quality, groundwater, and the water recycling, and the water utilizations are the key missions and objectives on behalf of our organizations. And as the government organization in the water cluster, we have conducted a lot of the project, and we also have about the 214 billion won as a total budget, including domestic and overseas the project. And the Korea ECO, K-ECO, is the one of the integrated the convergence and R&D organizations. So we also have the 22 billion won for the total budget as of this year, and probably we also have about the 30 billion won for the R&D budget, and we also have a total of the 60 billion won as of all the total the budget for our operations and the project. Of course, let me also give one example. And these days, one of the cutting-edge technologies in the COVID-19 era, the medical industry, IoT, ICT, and how to utilize and how to access the machines are one of the key learning the points. And the other point is the self-driving vehicles. Without the coordinating from the human personnel or the input, the machine cannot really fully control, leading to some of the unexpected accidents. So how to really make the comments into the system is also one of the key areas that we are going to cover in the future. And even though we have a very huge, excellent level of the technologies, absolutely big data is to be managed by human workforce. And somebody absolutely give directions and comment into the system for the full operations. Drones, robotics, and absolutely we also have to take look at the drones as one of the cutting edge technologies for collecting the water quality data as well as the air quality resources. And we can also reduce the time and we can collect the data in real time. In this regard, and as with the smart project within Korea, and probably as far as I know, the process will be done by the 2023, but the Korean government project will be done about 2024 with about the 1.8 trillion won as the amount of the budget for the valves or the sewage facilities will be also improved and renovated by the systems. And in order to develop those systems and the developments, we are also working a lot of the efforts to really promote those systems. So probably it's also high time that we are going to exchange and learn more best practices from Singapore as well as the US. So I really do hope that we can learn a lot of the very fruitful outcomes and technologies so that as one of the leading countries and the water welfare as well as the water issues together, I do really hope that we can collaborate together for solving these challenges. Thank you.
Thank you. Mr. Lee has talked about the role of Korea Environment Corporation as well as smart water management at the uh, water cluster. So, Mr. Yuan, can you comment on Mr. Lee's comment and also answer the question that you had earlier?
A few thoughts that came to my mind. Number one, if you refer to my earlier presentation, I mentioned the key reasons why we embark on digital transformation. I think the primary reason is because of efficiency, doing things better, faster, safer, right? And now public expectation is very high. Service quality is important to them. So therefore, through digital, we are able to provide better service to the customers. You are able to provide real-time understanding of the system, be able to provide faster response to some of the potential problems that might come out during the course of operation. So I think maybe just to contextualize it, let me give you a few examples. So for example, in terms of, I mentioned earlier in my slides the smart meters. So that one, we are installing them. A customer through the app, they will be able to know their real-time consumption. And so if there is a spike in the water, then we know there is a problem. We can be able to respond quickly. I think that one, I think is quite self-explanatory. Now, in terms of operations, I can have three examples I can share. Number one is the sewer network. So sewer network, of course, you know, is a very dangerous job, right? Going sewer inspection because of the H2S, and it's a very dangerous operation. So through using autonomous vehicles, we can then we don't have to rely on human manpower to go in and inspect our sewers. We send in a robot with a camera, and through that, an operator will sit outside and just control the robot. The robot will go inside. If there's leaks, there's problem in the sewer pipe, straight away this will be picked up. An extension of that is our deep tunnel. You know, Singapore, we have this deep tunnel sewerage system. So these deep tunnels are 50 meters below ground to 100 meters below ground. These are huge 2.4 meter tunnels for wastewater, and they are built for 100 years. And basically, there is no way for somebody to go down and inspect. These tunnels have already been in operation since 2008. It's almost about 15 years. What is the condition inside? Nobody knows because you can't go in, right? So we are using using drones to fly into the tunnel from one shaft, fly inside to see and come out the other side. Obviously, with drones, you know the challenge is what? The challenge is connection, the signal. You know, when you go inside, when you fly a drone in the air, it's okay, right? Because you can control, right? The problem with a drone in the deep tunnel is the signaling. So these are some of the challenges that we are talking with companies, solution providers, to adapt an existing drone technology that can fly into a network that has no GPS signal because it's 50 meters into the ground. So these are some of the so-called autonomous smart technology we're trying. The other one is water quality. We have reservoirs. We have many reservoirs in Singapore. We are concerned about the quality of the water in the reservoir. And so what we have done is we have implemented real-time monitoring system. We designed it creatively into a swan, you know, those white swan. And we install the sensors into the swan, and then the swan will move in the lake and looks like real swan, but actually they are fake. And they will collect water sample, and they will do the testing, and they will report back to our operations real time. So in other words, it's a continuous sampling, as opposed to somebody going down to take samples every hour. So that is another example, right? And then I guess the last example is about rainfall. Now in Singapore's case, we are in tropics, so we have huge rainfall every afternoon, big rain, 2 hours, right? And so what we have done is we have built in a predictive monitoring system to look, and with this one we talked to our colleagues who are doing the meteorological station. We built in the system to predict where the rain will fall, what time it will fall, so that our response team will be on the site before the rainfall. Because once the rainfall, flooding happens, public will be unhappy. So we do the predictive modeling such that to the precise point of when the rain will be falling, and then our team actually are deployed there before the rain comes, so that when the flood happens, our team is already there. So I think these are some of the digital solutions that we are putting in place. Again, coming back to the first point, public expectation, service quality, operation, safety. In terms of then your question about how does that link with energy, I think currently it's not, the digital transformation doesn't quite address the area of carbon neutrality. That one has a different programs through R&D technology, not so much about smart. Smart is really about service quality, customer, doing our operations more efficiently and effectively.
So you are concerned about localized kind of maybe it's kind of digitalization for operational maybe guidance or the water quality things. But I'm mentioning about some integration of all the water systems. So from water intake, water treatment,
Yes,
water distribution.
of course.
You should think about maybe whole objective function.
Yes, of course. Sorry, so I didn't mention it. So when we talk about by breath, actually, because PUB, we manage the entire water loop from catchment to treatment to wastewater, then to new water and desalination, right? So at a system level, we do have a monitoring room, a joint operations room, which basically controls the entire system, have an overall view. Because what has happened is, for example, today, how much water do we need to produce to meet the demand, right? And our network itself is an integrated network. So we will decide what is the load. Then the wastewater treatment site will then have to manage the load. Then that will come back to the new water, how much new water to produce. So at the system level, that is where all the different sensors will come in to help us to look at it at a system level. How do we manage it as a utility? So smart is at the system level, at the plant level, at the network level, and every one of it has its purpose. But again, coming back of efficiency. How do you manage it efficiently? Thanks.
네, 유한 씨께서 이제
Thank you, Yuan, for improving services and efficiency, introducing robots and sensors and drones, and monitoring reservoir water quality. These were things that you shared with us today. So on the floor, we also have many distinguished guests with us. We still have about 10 minutes. So I think we have time for about 2 questions, comments or questions. Please feel free to raise your hands.
네. 우리 제이텍의 최윤희 대표님께서
From JTech, we have CEO Choi Yoon-hee. I am Choi Yoon-hee from JTech. I have a question for Mr. Yuan. You mentioned earlier that you mentioned about the reservoir water quality regarding the real-time monitoring in a swan shape. So how long did it take for you to actually implement that? And what kind of data is being collected through that device? The reason I'm asking this question is because I like fishing. But in Korea, the reservoirs where we can fish, I go once in a while to fish. But in 2012 to 2013, these reservoirs, when we go there, we were very clean. Shrimps or fish that are very Korean native. These kind of species that live in very clean waters were observed, but in a few years, they all disappeared. And they look very weird. You know, they have a lot of defects. So recently, they did an environmental investigation, and because I am also in this industry, I looked into the details and I thought that these reservoirs should be preserved and saved. So regarding the water quality of reservoirs, so I'm really interested in what you mentioned about that real-time system shaped in a swan.
I am not in the water quality department, so I won't be able to give you the specific answer in terms of the quality parameters, but it would be the typical water quality parameters like DO and some chemicals, but I don't have the exact details, right? But I think but to answer your question in general, you are totally right to say that I think in PUB's case as well, water quality is obviously very important. And therefore, the SWAN basically helps us to be able to track, do real-time sampling. But I also maybe just to so I can't answer your question. Maybe if you can give me your context, I can maybe see whether I can get somebody to answer your question specifically. But maybe just an anecdote. In Singapore's case, recently over the last 10 years. Used to be our reservoirs are what do you call that? They are protected. They are protected because we say that, oh, this is important. We don't want public to go into the water. But in the last 10, 15 years, we have changed it around. We have decided that, in order to make the public value the water as much as we have to open the water for people to use. So we are doing a lot of kayaking, a lot of sea water activities to make sure people understand and value the water as much as we do. So it becomes a community responsibility. And because we're doing it, actually, to be honest, the last 10 years, we have seen a lot of growth of, otter, OTTER. So now there are 4 or 5 otter families living in our reservoirs. And the otters are very sensitive to water pollution, and they are thriving in our reservoirs. And I think that is a representative of the fact that the quality is good. But I can't answer your question, unfortunately. I don't have the data with me, but I am able to share with you after that.
예, 감사합니다. 마무리하기 전에
Before we close, Jordy and Brian, do you have any more comments?
No, thank you.
오케이, thank you very
Very
much.
interesting.
예, 예. 지금 그 장시간 동안
So for quite a long time, we've been talking about digitalizing water. There were a lot of different opinions and thoughts and comments, and Mr. Yuan also gave a very good answer. We talked about many different things, but ultimately, why are we pursuing digitalization in water? And what do we ultimately want? Is it efficiency or carbon neutrality or financial matters? We have to define what we actually really want. And creating and collecting the data, valuable data that we need, and using an AI to make the judgments will be important. But still, at this point, like Mr. Lee mentioned, the final decision is made by human beings. Therefore, we have to gather our wisdom and go towards a desirable way. So for quite a long time, we have gone through presentation and panel discussions. So thank you for your participation. Thank you.
예,
This wraps up the first session. To all the panelists, presenter, moderator, thank you very much once again for your time. You're going to take a 10-minute break and then resume the second session. So from 3:20 as of the Korea Standard Time, you're going to resume the session too. Thank you. Hello, can you hear me? Can you hear me? Dr. Anderson, can you hear my voice? Dr. Anderson, can you hear me? This is the Rachel, one of the interpreters for today's forum. Can you hear my voice? Testing, testing. Can you hear my voice? Can you hear me, Miss Dr. Anderson? Can you hear my voice? Hello? This is Rachel. Can you hear my voice? And please unmute your microphone so that we can hear your voice. 아직 안 들립니다. Dr. Anderson, can you hear my voice? Please unmute your microphone so that we can hear your voice, Dr. Anderson. Dr. Anderson, can you hear me? Please unmute your microphone so that we can hear your voice. Are you joining here on the Zoom? Dr. Anderson, can you hear my voice? 네네. 근데 저희도 이거 들으셔야
셋, 둘, 셋, 둘, 셋, 셋. 지금 들리시나요?
Dr. Anderson, can you hear me? Dr. Anderson?
Just a minute. Hello, can you hear me? Okay, so our microphone works. It looks like something is not open. We can't hear your voice through Zoom. So everything's fine on your side, I guess. But yes, there's something wrong that we can't hear your voice on Zoom. Just a second. 여기서 그럼 어떻게 해야 되지? 저희 다 들린다고 하시거든요. 이걸로도 들리고.
근데 터졌다고 하는데. 이분도 많아.
Can you share your screen? Yes, yes, we can see that. Are you using a desktop or a laptop? Okay, laptop. No, actually, music, it's just background music here. Do you have a headset or something that you can an earphone or headset that you can use? Oh no, they were just speaking in Korean. Yes, yes, we can all see your presentation, but the thing is, yeah, through Zoom we can't hear you. Please be just a minute. 그러니까 뭔가 저희 쪽에서 지금 Dr. Anderson?
Yes.
Oh, just a minute.
Can you hear me now?
Oh yes, it works.
Okay, so we can shut down the phone?
Okay, yes, we can shut the phone and I will talk to you through Zoom. Okay? Okay, I'm talking through the microphone here. Hello? Hello?
Hello?
Oh yes. Yes, we can hear you now. I think it's all
perfect.
set.
Perfect.
Okay. So, okay, see you later. We'll begin shortly.
Yeah, no problem.
can you hear me? Dr. Anderson, can you hear my voice? I'm the
Will you give me 1 minute to see if I have something in my office?
네, 그럼 두 번째 세션을 시작하겠습니다. 이번
We are going to officially the second session, and we also have the theme of the climate change and countermeasures. So for the second presentation, I'm going to introduce the presenter, Dr. Anderson from Denmark, and he is the professor for the Danish, the cluster, and the professor is the VI University and Clean Cluster in the Denmark, and he's going to introduce about the best practices and the cases from the Denmark. So he's joining us on the online platform. Let us give a big round of applause.
Dr. Anderson, please start.
Yes, okay. Hello, everybody. I heard there's a little bit issue with the sound, but I hope you're able to hear me. First of all, thanks for having me do this presentation on behalf of Clean and VIA University College. I would like to tell you a little bit how Denmark is preparing for the future and present climate changes. My name is Thijs Rosgaard Andersen, and I'm the head of research at VIA University College. And throughout the last 10 years, I've worked with climate adaptation solutions. Oh, sorry about that. Yes, just a little bit info on Denmark. Denmark is the southernmost of the Scandinavian countries with a population of around 6 million people, and Denmark consists of a peninsula, as you can see on the picture, and Jutland, and a lot of islands. We have around 450 of them. And Denmark, as you can see on the elevation map on the left, is characterized by a flat arable land and sandy coast, and we have a low elevation. The highest point in Denmark is only 180 meters above sea level, and we have a temperate average mean temperature of 9 degrees. As mentioned before, we are a small country, but we have almost 9,000 kilometers of shorelines. So we have a huge amount of shoreline compared to our country size, and that makes gives us some challenge with respect to climate changes. And the red circles, they represent case studies that I will tell you about, and they represent 3 different levels of climate adaptation solutions, or governmental levels of climate adaptation solutions in Denmark. So, like every other countries that we are looking into 2 different ways when we are preparing for the future climate changes. First, of course, is climate adaptation, and that is what I will focus on today. But of course, we also have the other one is climate mitigation, and that is, of course, lowering the CO2 emissions. So these 2 ways of working should go hand in hand. And at least in a Danish concept or aspect, you can say, when did we start working with climate adaptation? And at least in Denmark, we can say that most likely it started the 2nd of July 2011, when a major rain event hit Copenhagen. And that is the picture on your left side, where you can see the car is flooded. This rain event 10 years ago, it caused over 90,000 damages on houses, and the insurance companies, they had to pay almost €1 billion to the citizens. So after that, the Danish government, they launched a strategy, a climate adaptation strategy, where each municipality should have conducted a climate adaptation solution plan for their municipality within 2013. So 2 years after this huge rain event, all municipalities in Denmark had a climate adaptation plan that they're actually following now. On the sides, on that, just a brief, this is the only slide about climate mitigation that I will show. But of course, it's just to illustrate that Denmark, like many other countries, have of course committed itself to honor the Paris Agreement targets. You can always discuss how good we are doing, but at least we're trying to do it. We actually made a climate law last year where we committed ourselves to reduce our CO2 levels in 2020 by 70% compared to the 1990 levels. And we need to have a fossil-free energy sector no later than 2015. And we need to be neutral as well in 2050. And of course, both of them are in order to reduce the CO2 emissions and to keep the temperature rise below 1.5 to 2 degrees as the Paris Agreement targets states. And I know there's a lot of water utilities today at this meeting, and I can say that the Danish water utilities, they have committed themselves to be climate neutral no later than 2013. So there's a huge transition going on in Denmark towards being CO2 neutral, or actually also CO2 consumers instead of adding CO2 into the atmosphere. But still, even if we are able to honor the Paris Agreement targets, we still have a lot of problems, simply because we have already made some irreversible changes to our climate. And so we need to adjust our society into the future climate changes, and that is what I will talk about today. Yes, you can say Denmark is challenged from three sides. From above, of increased, more frequent and heavily rain events, so simply we will have more rain than now. We have a huge problem with rising groundwater, and of course we also have the problem of rising sea levels from the side. So we have three challenges that we have to look into with respect to our climate adaptation solutions. And on the blue, you can just see some numbers on how many houses and how big the problem is. And for example, you can see that the groundwater is actually threatening 500,000 homes in Denmark, with a huge amount of with an amount that is extremely big if we don't do anything about it. So of course, in Denmark, this is a huge task, and we are really working on how to solve these problems. Yeah, just to summarize, if we look at some of the future climate changes, this is some climate models from the Danish Meteorological Institute. And on the red, you have our CP scenario 2.6. The blue is the RPC 2.6 scenario, and the red is the RCP 8.5 scenario. But what they both state is that we will have more rain, as I mentioned, we will have warmer winters, we will have warmer summers, and of course we will have higher sea level. Topping on that, we will also have a stronger storm, so we will simply have more energy into the system. So in general, you can say that Denmark will be challenged and threatened from three sides. So it's a huge task for Denmark. Well, the first climate adaptation solution I will tell you about is one of the biggest in Denmark going on in the moment, and it's 7 municipalities together with the local water utilities as well as the government, and they're looking into actually how to narrowing this Tuberan canal. The location is, as you can see on the left with the red circle, and what you see is you can actually see that this entire system here is actually a big fjord going in here. And when we have storm from the west, they're able to push all the water into this fjord, causing a severe flooding inside this entire water system. And on the left, on the right, you can see a more detailed map showing the entire fjord system. And one of the cities is here in Lemvig, and this is just one example how it looks when we have these floodings. So here you can see that the city of Lemvig has this brick wall in the middle of the town. So on the left you can see the water standing almost all the way up to the top of the dam, and on the right side you can see the traffic is moving around. So of course we already did some climate adaptation solution in the individual cities, but of course the big issue is that we need to do it for the entire system. So that's why they're looking into how can we actually do something about that. And the solution here is actually to narrow this canal that will feed all the water from the west into the system. So now it's around 1 kilometers in width, and what they want to do is to narrow it down to 250 meters. So of course, this is a huge project with a lot of consequences, both for the environment, but of course also for the industry and people in this area. But if you look at some of the numbers here, we can actually see that it's a good idea to do it. The cost of doing this is around 100 million euros. But as you can see that the expected houses that will be flooded in 2050, if you don't do anything, it will be around 20,000 houses. But if you do something, we are down to 7,000 houses. So we will not get rid of the problems, but we will definitely in making them smaller. Furthermore, we can see that even though it's the investment is large, we can see that the savings will definitely be worth it. Just the annual savings in flood protection will be 2 million euros. And if we can prevent one 100-year event, then we can save 120 million euros. So I will say that the take-home message here from this large-scale investment is that the climate adaptation solutions are often cheaper in the long run than doing nothing, and then don't do anything. And as well, at least in Denmark, when we have these huge projects, we need a close collaboration between the government, the local municipalities, as well as the water utilities in order to make this happen. But they will start to construct this very soon. So this was a huge-scale climate adaptation solution in Denmark. Now I will go down to a more local, medium-scale climate adaptation solution, and this is from Horsens City, where I'm actually sitting right now. And you can see the location of the Horsens City on the figure on the left with the red circle, and on the right you can see this is Horsens City, and you can see this entire catchment area or creek system. It goes into a lake here called Bygholm Lake. And when we have a lot of rain here, the city will be flooded from this entire rain or catchment area here down into the city. Furthermore, Horsens is also flooded from the ocean when we have sea level rises. So the Horsens City is actually working both on how to mitigate or change the flooding due to rain, but also how to reduce the flooding from the oceans. One way of doing it, here we have the picture shows the Bygholm Lake. And what happened last year was actually during a really long and big rain event, that the lake was actually almost full, and the dam you can see here just here. This is a dam. It was starting to be full, and it was starting to almost break. So they need to open up the sluice to simply lower the water in the lake, and then it caused flooding in the city. So what they have done now is actually to build up a new dam that is larger and stronger. So now they can actually hold a lot more water. So they have made this lake into a huge buffer for the city, but they have also made a stronger dam. So that is one of the solutions Horsens is doing. Another one that is also extremely big is that if you look here on the right, the red lines indicates the new road systems in Horsens. And as you can see, one of the roads is going around here. That is the outer ring of the road, but it passes through the harbor here. And if you look on this picture here, you can see that they're actually building a dam through the harbor in order to protect the city from floodings from the ocean. The dam will be 2.6 meters high, so it will be able to at least the first many years protect the city from flooding. Furthermore, it actually turns this entire basin area here into this harbor area into a huge basin. They added a pump or sluice, so they're actually able to pump out the water when they close down the harbor system. So now the city actually have two buffer systems. They have the Bykom Lake up here, and then they have the harbor area here. And they have actually built a dam here, and then they're starting to build dams all the way up here in order to protect the city from the oceans. So they're working on two sides from the backside with respect to the rain, and from the oceans with respect to dams. And furthermore, they're starting to transform the entire inner city into a blue-green system. And simply in order to making the city blue and green, reduces the pressure on the sewer system, simply because you don't have to add a lot of rain into the sewer system. Now you can either add it into the green areas or add it directly into the ocean here, instead of having it going through the sewer system to the water utilities. So now they're starting to transform the entire city into this blue-green system. And just some illustrations of how it looks. On the right, you can see this is how it looks now. And on the left, you can see how it will look in a couple of years. So the take-home message from this is actually that these climate adaptation solutions, they hold an extremely important opportunity for us to change our city into more livable and beautiful cities. I just have a few pictures. You can see how it will look in the future. So of course that will be a fantastic city to live in, green, blue, instead of these gray concrete cities that we have now. So to summarize with this medium-scale climate adaptation solutions in Denmark, for me, these climate adaptation solutions that we have to do in our cities in Denmark, and we have to do it all around our cities in Denmark, they actually have a huge amount of opportunities for us to change our city, transform our urban spaces into nicer and more vibrant cities. And there's so many good sides of turning our cities into more green and blue. We have cleaner air, we will have noise reduction, we will have an increase of biodiversity. We actually see that crime is falling in the cities where you have a lot of nature. The house price is rising. And furthermore, we can actually create spaces where people can walk around, exercise, and meet. And especially during this Corona pandemic, we can see how nature is actually getting back into people. And so I think this is just again taking something that we need to do in order to protect our cities, but we can transform our cities into something fantastic. So again, take something that is not very good, but change it into something very positive. And finally, I will show you just one example of a more local scale climate adaptation solution. And this is made in collaboration with RIA and the local water utility and the municipality. And that is what we call the climate road. And in the climate road, we try to combine the climate adaptation solution together with a climate mitigation solution. So the whole concept of the climate road is that we have a traditional road where we have added permeable asphalt. So all the rain that drops on the road will actually seep into the roadbed. And in the roadbed, we have installed a geothermal system so we can extract the heat from the rain as well as of the surrounding soil. And that heat we use to heat the nearby kindergarten. So we have this combination of climate adaptation solution and climate mitigation solution. Yeah, So this is a proof of concept. This has never been done before, so it's not a very big, it's a prototype, but so you can see it's only 50 meters long and it's 1 meter deep and it's 8 meter wide. But this 50 meters of road is actually able to supply all the energy needed for a kindergarten of 900 square meters. So the potential is huge. Yeah, just how does it look? Yeah, as mentioned, the road is made with permeable asphalt. So as you can see, compared to normal asphalt, you can see that the grain size is much bigger, and you have voids between the grains, so we're able to infiltrate huge amount of water. So as you can see on the picture on the right, you can see that the infiltration of this road is extremely high. So every time rain hits the surface, it will simply seep into through the asphalt into the roadbed. In the roadbed, we have a capacity of 30% porosity, so we can actually, in this road, we can store 120 cubic meters of surface water. So we can store a huge amount of water in this system. And this is just how it looks. With the white, we have these bentonite mats, and it's simply to separate the system from the surroundings hydraulically. Then we have these 800 meters of ground source heat pipes in the system, and then we have this gravel where we can store the water. So so far we are able to extract 50,000 kilowatts hours annually from this system, and that is sufficient to heat the kindergarten. You can see the kindergarten just up here. Yes, and this is, I will just go through this very fast. I can see my time is running out. Some of the advantages with the climate road is that we will have always a dry road, and you can do many things with a climate road that you are unable to do with a traditional road. So it has a huge potential, no question about that. Yeah, of course, we also have the geothermal system, and this provides green, sustainable energy to the kindergarten. Another advantage of this system is that it doesn't take up any space in the urban environment, simply because it is installed in the roadbed. So it's not a problem to have it there. So just some conclusions, and I will go through this very fast, that this climate road has been a climate adaptation solution that has performed very well. It's actually outperformed our expectations. We didn't have any floodings in the area at all, and we're able to produce much more energy from the system that we expected. So we are working on version 2 of the climate road, where we will add more houses into the system. We will look into how we can remediate the water, and stuff like that. I will not go into detail with that. I can see my time is running out. Yeah, so I'll skip this. Some concluding remarks. I can say Denmark faced major climate challenges as the rest of the world. But at least in a Danish perspective, we are able to solve them, at least in a short to medium time period. I mean, we have the means, we have the necessary knowledge, and we have the decision-making power to do it. And I think this combination is extremely important. We have the municipalities, companies, and water utilities. They are very skilled, and they are up for the job together with the universities. And probably the most important thing is that the citizens, they want climate adaptation solutions, and they're willing to pay for it. And I think my take-home message from this presentation is that these 3 climate adaptation solutions or projects I have illustrated for you is that we can adapt pretty much us out of everything, but only to a certain limit. I mean, there is a limitation to everything, also climate adaptation. And what we are working in Denmark is that we can use these climate adaptation solutions to resolve a problem. I mean, that could be a lot of rain, that could be flooding and something like that, and use them to create a solution. It could be, for example, more energy in the climate road. It could be the dam where we build a road and so on. So we actually take the climate adaptation solutions and make them useful for the citizens. So you will have a dual purpose of almost every climate adaptation solution in Denmark. Furthermore, climate adaptation solutions are in many cases cheaper in the long run than traditional solutions. And the climate adaptation solutions are implemented in all governmental levels in Denmark, from the municipalities to the regions to the government, in combination with or in close collaboration with the water utilities. But of course, no matter how we look into it, of course, the only way, the long-term run, or the only way we can stop this, let's say, bad way, or the only way we can stop this is, of course, if we start to honor the Paris Agreement and start to lower our CO2 levels in order to reduce the consequences of this changing climate. Or else we, in the long run, we cannot adapt us out of this problem. Yes, thank you for the attention. Any questions?
예,
Thank you very much for your presentation, Dr. Anderson. On the topic of climate change and countermeasures, we will proceed with the panel discussion. The moderator for this session is Professor Choi Ik-hoon from Yonsei University. Please welcome him with a big hand. Professor Choi used to work for Korea Environment Corporation and is currently a professor at Yonsei University. Please, the mic is to you. Thank you. Dr. Anderson from Daegu University, thank you for your presentation. So this is an online event, and I believe that Dr. Anderson, it's very early in the morning for you. And for those joining us from the US, it's very late at night. And despite such time differences, thank you very much for participating. And the panels for today, I'd like to introduce them. From the American Water Works Association, we have President Shio-ho Sham. Are you there online?
예, 예, 다음은
Next, from WIPTEC, we have Barry Liner, CTO of Water Environmental Federation.
Okay, let's write the check. 야, 예. 그러면 먼저
And then the panels from Korea. From KWCC, we have Mr. Lee Jung-gun. Let's welcome him with a big hand. From Kumo National Institute of Technology, we have Professor Lee Won-tae. My first question goes to Mr. Chio Sham of AWWA. As an overseer of the United States Water Works, I want to ask the question to you. An interesting point pointed out by Dr. Anderson, climate change and climate mitigation-wise, regarding the climate road. The basic concept of climate road is using energy. And related to that, a question goes to Mr. Chio Sham. So waterworks, it actually use a lot of electricity. So does sewer plants. And in terms of climate change crisis, to save energy use, what are the directions of the United States and your institute?
energy in America. Yeah.
Well, I'm having some difficulty understanding the question, but I know what I'm supposed to talk about is relating to climate change and the impact on the water sector. And I think I'm very glad that actually Barry Liner will be with me because I'm representing the American Water Work Association, which really focuses on the drinking water side of the urban water cycle, and Barry worked for the Water Environment Federation, which they focus on the wastewater side. But obviously, the distinction between drinking water and wastewater tend to be arbitrary because we should really be thinking about one water. And actually, some of the solution when we're dealing with climate change should be really be on a holistic using a holistic approach, not just looking at drinking water sector versus the wastewater sector. And of course, we still also have other issues relating to stormwater. That's what we just heard earlier from Professor Anderson. And so for me, what I'm looking at is that absolutely, there are a lot of challenges that are facing the water sector because of climate change. And also being a part of the United States, given it's a large country, that there is a 330 million population. And also, if you're looking at the climatic zone, the U.S. is very different when you're comparing what you will see in the northeastern portion of the United States versus the southwestern portion of the United States. So I think it's really difficult to sort of generalize what might be the response. So all we can really think about is that the climate change, clearly, some of the signal is going to be in the hydrologic component. And what that might imply, as indicated earlier on in the earlier talk, is that precipitation pattern will change. And that change could be on the intensity, the duration, and the frequency. And all of those will manifest into responses on the land surface, which can also affect how water is being conveyed on the land and then being stored and also being used. So there are all these other impacts. Like if you're from a specifically drinking water point of view, let's just use an example from the public health on microbial contamination. What we do see is that if you have more intense rainfall event, generally that will precede the outbreak of some micro disease outbreak. So that's generally you will see that will be the case. And that's really more on the water quality point of view. You can also see it from the water quantity side. And so if you're looking at sort of technological solution, you will have to sort of fine tune it to figure out what might be the most appropriate technology. I also have been on the New England Water Innovation Network for a number of years. So obviously there are a lot of technologists that are looking at solving problems that are basically facing the drinking water sector, whether it's contaminant removal, microbial inactivation, and those could be solutions that tend to be very silo. And so what I will encourage is let's really sort of start thinking about more of a holistic approach, taking into account the full cycle, dealing with the urban phase of the hydrologic cycle. That's one component. The other part that I also will encourage the folks in the water cluster to think about is the human dimension. We just heard about issue relating to COVID. And if you come to the U.S., you can definitely see is how people respond to COVID is also very different. There are folks that run to vaccination, and there are people that run away from vaccination. And so it's not that simple. They would just say, oh, that will be just a common response. And so regarding to the governance of water, regarding to how we are actually valuing water, that it's also going to be very important. So I think we're going to be looking at some very challenging time, looking at a changing landscape with regarding to water availability and water quality, and I think that would be a prime time for innovators to actually come together, collaborate, which is also some of the word that I heard in the earlier talk, to work together to actually figure out how we can solve some of these problems much more comprehensively and holistically. Let me just stop right now, and maybe I'll turn it over to Barry, because I think I worked with Barry in the past, and he can definitely will share some of his insight in how to deal with this particular issue.
Okay, thank you. Yeah.
So I think President Cheo Sham gave a good answer regarding the complexity of the issues that we are facing. It's really difficult to give a single answer to that. But for better water quality, we need to think about reverse dam sheet and other technologies and methods in order to overcome these issues. I think Barry Liner should have something more to talk about this. Barry, are you there?
Yes. So,
Yeah, thank you.
thank you very much for the opportunity to speak. We were pleased to see all of our partners from Korean Water Partnership at Left Tech earlier this year, and I also would like to echo my support of everything that my colleague Jiho just shared. Now, one of the challenges that we're facing with technology and innovation around climate change in the States is that the reacting to an event, this is when Dr. Anderson was talking about the flood from 2011, when we react to an event at big utilities, it's easier to get money and to solve some of the problems of hardening, structural hardening of the infrastructure, because that's kind of the core business of a water wastewater utility. So if the pump station floods, then it's easier to build that back because you can prioritize the money because you do that. To prioritize something around greenhouse gas mitigation or even energy efficiency is often a challenge, because even if you have large savings that you might see in terms of saving a lot of energy and money, the prioritization with all the aging infrastructure and fixing things really often drifts back to the core infrastructure and the core business of what the utilities are doing. So there is an opportunity for the water cluster innovation hubs to actually seize the opportunities when those events happen, where we need to rebuild the infrastructure and take some of these innovative practices and technologies and put them in place. And I think we saw that earlier in the previous discussion too, from Singapore, and talking about the AI and smart water too. So I think the challenges of trying to prioritize hardening and resilience for climate change, and also looking forward towards some of those mitigation activities is a challenge and an opportunity for us looking forward.
Thank you. 우리
to look at these future directions. That's why we are conducting the water cluster. And around the world, we also have to induce the more collaborations on behalf of the global water partnership and the water clusters, leading to more opportunities, as you mentioned earlier. In this regard, I'd like to also ask some questions and issues to the president of the KWCC. When it comes to the water partnership within Korea, what roles and what direction should we focus on in the future? Nice to see you all. I am the president of the Korea Water Cluster Conference, KWCC, for the climate change and the carbon neutrality. And I'm going to share with you how we are going having some the measures and the plans in these two elements. And when we really held the academic the completion ceremony for the ESG, and we also talked about the issues for the COVID-19 outbreak, along with the climate change, as well as the destructions within the ecosystems, along with the outbreak of the COVID-19. And at the forum, we also listened to the presentation done by the former Secretary General of the UN, Ban Ki-moon. Zero or carbon neutrality or net zero should be absolutely achieved. As also touched upon by the President of Republic of Korea, Moon Jae-in, at the UNFCCC, the carbon neutrality, along with the reduction in the greenhouse gas emissions, should be absolutely reduced by 40% by 2040 compared to the pre-industrial levels as one of the national commitments. In this regard, as we are living in this reality, the water utilities and the businesses, and on behalf of the Korea Water Partnership and the KWCC, the carbon neutrality and the green growth are urgent issues and the challenges, and these are objectives that we have to solve as soon as possible. On behalf of the KWCC, as July this year, directions for the green growth as well as the carbon neutrality, and every month we are hosting a regular presentations and seminars. And by utilizing the qualified water systems and technologies joined by the businesses, the cutting edge the technologies are also being shared and reviewed on a more regular basis, leading to the more continued development in the water partnership. So I do really hope that we can take a leading role in developing our systems, and these are our future directions. So thank you very much for listening. Thank you very much for sharing good comments, President. The theme of this session is the climate change and the countermeasures, as also presented by the US and the Denmark. We also listened to a lot of the status and the directions. International coordination and cooperation are much more looking forward to really set the future direction.
Now, Professor Lee Won-tae from Kumo National Institute of Technology will speak. I have a question to Professor Lee regarding sewage plants. So in waterworks, 1.4 million tons of water, 1.4 million tons of CO2 comes out through waterworks, and 4.3 million for sewage works. So and a total of 0.8% of CO2 comes out there. So about 0.8%. That may be small, it may be big, but in the public sector, we need to come up with an alternative for that. We need to find ways to overcome this. So in utilities, whether it be energy or carbon emissions, how can we monitor these and how can we make efforts difficult question. Before I give an answer, I have a question for Dr. Anderson. Can I ask a question first?
I have problems hearing the questions.
Are you there?
Yes,
I
yes.
didn't ask anything yet. I'll ask. I have two questions to
Yes.
you. You talk about many technologies to adopt climate change from large scale to small scale.
Well, I think
so my question is, can you share your experience with mitigation for climate change in Denmark? Some of your experience.
Yeah, well, yeah, that's a huge question. You can say if you look into start with the energy sector, you can say that we are moving from fossil fuels to to green sustainable energy sources. In Denmark, it's primarily wind windmills as well as geothermal energy. That is the main sources of energy in Denmark. But of course, it depends on the country, which opportunities you have. With respect to the local, you can say Denmark is we are blessed that we have a district heating that covers 60% of all houses in Denmark. So the green transition with respect to energy is fairly easy in Denmark. And what we do is that the water utilities they actually trying they take all the energy they produce from the wastewater utilities. They take that and add into this district heating system. So it's actually easy for the water utilities, or easy. It's doable for the water utilities in Denmark to actually to add their energy into the district heating system in Denmark. Thereby, we can actually have the water utilities. It's actually many wastewater utilities in Denmark is actually energy producing at the moment. So that is one way that the water utilities can work on that. So of course there's a huge technology development in that sense, how to first of all lower the gas emissions from the wastewater utilities, but also how can we take all the energy we have and add it into the system. Yes, and then of course, with respect to the climate road, we try to combine, as Chi Ho said, that we look into the whole water cycle. So in that case, we take actually the rainwater, we use that to heat up the kindergarten. So again, combine the solutions. We do a lot of that.
Okay, thank you. 그래서 제가 여쭤본 이유가
The reason why I asked this question is because, as mentioned by Dr. Anderson, renewable energy, the use of renewable energy or alternative energies are possible. So, as Professor Che mentioned, the basic facilities that we have in Korea, we need to come up with technologies on how to reduce CO2 emissions in our water processes. So to elaborate on that, I think we can think in two different ways. So the first is indirect reduction of CO2 emissions. And the way is to use renewable energy, solar energy, or Denmark, you mentioned wind energy. But in Korea, we're not a very good environment for wind energy. So in our case, you'll probably saw a lot of solar panels for solar energy in Korea. And for wastewater treatment facilities, using gas or hydrogen as energy sources. So these kind of new renewable energy can be one way. And another way is basically for wastewater treatment facilities, it uses a lot of energy, and the pumping facilities use a lot of energy, in particular. So those equipment and devices need to be more efficient. By doing so, we can reduce the amount of CO2 emissions. So those two are the common things that all the facilities should focus on. And CO2 reduction Carbon, we need to think about CO2 emissions, but along with that, we also need to think about other aspects. It's all included in reducing carbon emissions, not just CO2. So from the Ministry of Environment, I think by 2030 or 2050, we want to include we want to manage the wastewater treatment facilities to use energy produced internally and put that number up to 50%. It's a long way to go, but I think we can do something about that. I also have a comment.
And in Denmark, especially in the European countries like the Stockholm and the Sweden, the pilot projects are ongoing a lot. And I just do also wonder that the heat recovery from the sewage water, are you also doing the processes or the pilots in your country as well?
I didn't hear did you have a question for me? I didn't hear it then.
I will repeat again. As I know, near your country, like the Sweden, Stockholm. Yeah.
Yes, we are close to Stockholm. Stockholm is the capital of Sweden. Yes.
스톡홀름 같은 경우에는 하수열 회수를 하는
There are the heating systems, and a lot of the projects are ongoing and recovering the heat from the sewage water in Stockholm. So I just wondered that the Denmark has been also done some collaborations with the Stockholm.
saying about the energy recovery of sewage heat. Okay, I think 우리나라에서
In Korea, as I mentioned before, as there's a professor, Mr. Lee, mentioned earlier, as of 2015, the heat recovery project from the sewage water has been actually conducted as an independent project before, as of 2015. And especially in the northern countries like the Sweden and the Stockholm, they have been conducting a lot of the project regarding that issue. So I do really hope that, as there's a professor Anderson mentioned earlier, like the climate adaptation and mitigation, probably your region is very closer to the Stockholm. And I do also wonder that the Copenhagen, the capital city of the Denmark, has also done some collaborations with the Stockholm.
Okay, yeah. Now, 나중에 우리가 직접적으로
Okay, probably we can ask and deliver that question to the Professor Anderson later. And I do really hope that it's also a very opportune time to listen to some of the issues, not only from the US, but also from Denmark and around the world. And the climate change is the objective that we cannot really avoid. That's why we are gathered together at the forum here, hosted by the Korea Water Partnership, in order to overcome the COVID-19 crisis and to meet the stakeholders in person later. And I am looking forward to putting more wisdoms among the stakeholders in the industry. And we are also joined by the online participants, even it's a very early time in the local. Oh, I missed getting the question from the floor. So if you don't mind, could anyone can ask any questions from the floor if you have?
예, 없는 걸로 알겠습니다.
Assuming that there are no further questions from the floor, and it's also the time that we have to wrap up today's forum. As mentioned earlier, due to the COVID-19, I have also participated a lot of the online seminar and the webinar, and due to a lot of the time jacks and differences among the different countries, I am pretty sure that the Dr. Anderson is joining us in a very early time in the morning. And also the President Chi Ho-shem is also joining us probably in the very delayed time. So I do really hope that in the future, the Korea Water Partnership will be also doing its best efforts and dedications to invite you and meeting you in person to talk about more fruitful outcomes and the policies in the water project. Thank you very much once again for your participation. Thank you, everyone.
예, 감사합니다.
Thank you very much. This will be the end of this session. So from now on, this is the end of today's forum. Despite the challenges of the COVID-19 pandemic, I'd like to extend all the gratitude to all the participants from online as well as offline. While we were planning to host the forum for this year's, and compared to the last year's forum, joined by a lot of the stakeholders, and we shared policies and support measures. And for this year, this transformation and the countermeasures for the climate change and climate crisis have been discussed as the key themes throughout today's programs, along with the key objectives and the roles and responsibilities that are to be done by the stakeholders in the water partnership. Of course, due to the COVID-19, we also have some limitations to meet all the participants in person, but I really hope that we can meet all the participants and stakeholders in person for the next year's forum. So this will be the official end of the second World Water Cluster Leaders Forum. Thank you very much for your time and effort. Thank you.
그리고 그 통역 수신기는 책상에 있는 책상에 두시고 퇴장하시면 됩니다.
And please leave the interpretation devices on your table. Thank you.